Welcome to This Explainer. Today, we're diving into the invisible, lightning-fast architecture that's completely transforming customer service. We're talking about taking a frustrating waiting game and turning it into a virtually instantaneous transaction. We are officially pulling back the curtain on automated AI email response systems.
Seriously, think about your own habits for a second here. How long do you actually expect to wait for an email reply when you reach out to a business today? A few years ago, waiting hours or maybe even a couple of days for a simple response was completely standard. But now, that feels entirely outdated, right? Whether you're shopping online, checking your bank balance, or just asking a quick question at work, you want answers immediately.
So, to understand exactly how companies are meeting this crazy demand, let's bring in our protagonist for today, Sarah. Now, Sarah is understandably frustrated. She types out this email. I ordered my package 3 days ago and still haven't received it. Now, let's freeze time right there. Boom! The exact second she hits send, her message doesn't just sit in some human being's inbox waiting to be read. Instead, it drops straight into a highly sophisticated, automated pipeline. Let's break down this architecture. Sarah's message immediately enters a 4-step AI processing pipeline, completely bypassing the traditional human inbox. It goes receive, understand, retrieve, and reply. Sure, it looks super simple on the surface, but behind this seemingly effortless interaction is a massive web of artificial intelligence, machine learning, cloud computing, and language processing. All right, let's look at step 1, the brain, understanding intent. This first stop relies on natural language processing, or NLP. And look, this isn't your old-school clunky keyword scan where the computer is just hunting for the word package. NLP allows machines to actually understand human language. It identifies the sentence structure, it picks up on Sarah's underlying anxiety, and it successfully interprets the true intent of her message. It instantly knows, okay, this is a delayed order delivery issue.
Moving right along to step 2, the memory, real-time retrieval.
Okay, so the AI knows what Sarah needs, but now it actually has to locate the specific data to solve her problem. Think of this as the system's memory. By using cloud-based APIs, the AI instantly reaches out to external databases. We're talking about simultaneously pinging customer relationship management systems, order management databases, inventory, or payment gateways. In our scenario, it's fetching Sarah's specific shipping details, her expected delivery dates, and her tracking numbers in literal real time.
Which brings us to steps 3 and 4, the voice, crafting the reply.
Now that it's gathered all the required data, the AI generates a response using a large language model, or LLM. Because these models are trained on massive data sets of actual human conversations and support emails, the output sounds incredibly natural. It spits out something like, "Hello, Sarah. Your package is currently in transit and is expected to arrive tomorrow. Here is your tracking link. Thank you for your patience." Notice how that generated reply is personalized, professional, and seamlessly integrates her tracking data. It doesn't sound robotic at all, it's just a perfectly crafted customer service response.
And this brings us to the absolute most mind-blowing part of our explainer. That entire journey we just tracked, analyzing the complex intent of Sarah's email, reaching out to multiple databases to retrieve her specific tracking data, generating a personalized natural language reply, and sending it back, all of that happens in less than 1 single second. Less than a second. It's wild.
So let's look at how that's even possible in the architecture of speed, optimizing the pipeline.
How exactly is this speed built? Well, companies use a cocktail of highly optimized advanced tech to make this happen. First up, cloud computing provides the massive, scalable power needed to handle thousands of these emails at once. Then you've got GPU acceleration, which uses graphics processing units to process these heavy AI models way faster than a standard processor ever could. Next is parallel processing, and this one is huge. It means tasks happen simultaneously, not one after another, so the AI can analyze Sarah's intent and fetch her customer data at the exact same time. Finally, caching systems keep frequently used information temporarily stored in memory so the AI doesn't have to constantly dig through the main database.
But we've got to talk about the hidden hero in this architecture, vector databases. Modern AI systems use these databases to perform what's called semantic search. Instead of just matching exact words, vector databases understand the actual meaning and the similarity between sentences. This lets the system instantly grasp the context of Sarah's email, no matter how strangely or casually she might phrase it. To really put that into perspective, old keyword search methods were incredibly fragile. If Sarah misspelled a word or didn't use the exact term the system was coded to look for, it just failed. Semantic search, on the other hand,
understands the intent and context behind your words. It gets the vibe. This is exactly why this new AI architecture is so exceptionally accurate and incredibly resilient to the endless, messy variations of human communication.
Now, while speed and accuracy are fantastic, obviously we cannot forget about safety. Emails contain highly sensitive personal, financial, and identifying data. Because of this, the entire high-speed process we just discussed is wrapped in heavy security and threat detection layers. The architecture actively utilizes advanced spam filtering, phishing detection, heavy encryption protocols, and authentication mechanisms to detect suspicious patterns. It keeps malicious emails far away from both employees and customers, ensuring your data stays completely private. But hey, what if Sarah's email wasn't just about a delayed package? What if it contained extreme anger, a highly complex financial dispute, or really confusing language? Well, despite all this intelligence, AI systems aren't flying totally solo. Most organizations use a human-in-the-loop safeguard. The AI handles the routine, lightning-fast answers, sure, but if it detects high emotion or deep complexity, it immediately escalates the ticket to a human agent. It creates this highly efficient hybrid support system, blending AI speed with necessary human empathy and judgment.
And because this hybrid system is so incredibly effective, it's spreading like wildfire. Just look at how major industries are deploying this architecture right now. E-commerce uses it to track lost packages, banks use it to clarify account balances, healthcare manages appointments, and IT tackles tech support. It's providing scalable 24/7 assistance basically across the board.
So, where does this all go next? As researchers keep developing models that master tone, sarcasm, emotional urgency, and complex multilingual nuances with near-human accuracy, these systems are only going to get faster and smarter. Which leaves us with this final thought. If today's architecture can read, understand, and solve your problem in less than 1 second, what happens tomorrow when AI can predict your needs and solve your problems before you even hit send? Thanks for joining me on this explainer. Keep wondering, keep learning, and I'll catch you next time.